Hello and welcome to the second of 3 lessons on wings. In the last video, we learned about XY-Wings. So you may think that because today we will be talking about XYZ-Wings, that the logic here will be somewhat similar. But oddly, this is not true. Of the 3 types of wings we are covering in this section of the complete course, these XYZ-Wings work a little differently from the other 2. XY-Wings and W-Wings work on the principles of AICs and chains, whereas the logic for XYZ-Wings is a little more like that of a unique rectangle type 5. So let's go over to the puzzle board and I'll show you what I mean. Remember that in an XY wing, we have 3 cells and 3 candidates, but only 2 of those candidates appear in each of the 3 cells, like you see here. In an XYZ wing, again, we have 3 cells and 3 candidates, but this time, all 3 candidates will appear in the pivot cell like this. Now, since we used A, B, and C to denote the 3 candidates in an XY wing, let's stick with that. So instead of X, Y, and Z, let's call the 3 candidates A, B, and C. An XYZ wing will always have a configuration that looks like this or like this. With an XYZ wing, one of the pincers will always be in the same block as the pivot cell, and the other pincer will be outside the block in either the same row as the pivot, like you see here, or in the same column as the pivot, like you see here. If all 3 cells were contained within one house, you would simply have a naked triple, like this. And you would not need an XYZ wing, because the naked triple would allow you to eliminate any other instances of all 3 candidates within that house. So the 3 cells of an XYZ wing will never lie in a straight line, like this or like this. Nor will they all lie within the same block, like this. These would all be naked triples. Let's call the bi-value pincer cell in the same block as the pivot pincer number 1, and the bi-value pincer cell outside the block pincer number 2, okay? P1 and P2. ABC will be the pivot, then pincer number 1 will be AC, and pincer number 2 will be BC. Of course, A, B, and C can be any 3 candidates, but for these examples, we will use 1, 8, and 9. Candidate C will be 9. And just for the record, if both pincers contain the same 2 candidates, like this does not constitute an XYZ wing, and no conclusions can be drawn. Each bi-value pincer cell must contain 2 of the candidates in the pivot cell, but they must be different groupings or sets of those candidates, even though they will both contain candidate C. Capiche? So here is a typical XYZ wing. Remember that candidate C will be the one that occurs in all 3 cells. And as I will prove in just a minute, because of this configuration, at least one of the 3 candidate C's must be true. Therefore, we can be sure that any other same-digit candidate that can see all 3 instances of candidate C, i.e. that can see all 3 cells of the XYZ wing, can be eliminated as false. And there are only 2 places this can happen: here and here. No matter which of those 3 candidate 9s in the 3 blue-colored cells is true, it would negate both of the red-colored candidate 9s. Candidate eliminations can only be made in the same block with the pivot and pincer number 1, so there is only room for a maximum of 2 eliminations, as you can see here, because they must also see pincer number 2 outside the block. And if we are dealing with a row, they are going to look like this, or like this, or like this. And if we are dealing with a column, they are going to look like this, or like this, or like this, if at all. There may only be one elimination, or there may not be any. As I said, at least one of those three candidate C's must be true. Now let's prove that by taking all cases for all three cells. Examining all possible cases for a certain situation is one of the very best methods we have for testing the truth or falsity of anything in Sudoku. If all possible cases lead to the same conclusion, then we know that conclusion must be true. That's called a verity. So let's look at all 7 possible cases for the 3 cells of our XYZ wing. And let's start up here with pincer number 1. If that cell was solved for 1, then you would be left with a naked pair here in row 3, and one of those 2 colored cells has to be a 9. So those 2 red 9s would be false. And now, if pincer number 1 was solved for 9, of course the 2 red colored 9s would be false. You can see they disappear. Okay, so now let's go to the pivot cell. If the pivot cell were solved for 1, then pincer number 1 has to be 9, and the 2 red 9s disappear. And if the pivot cell is solved for 8, then this cell is a naked single for 9. Okay? And then if the pivot cell were solved for 9, of course, it would negate those 2 red colored 9s. Now let's go to pincer number 2. If pincer number 2 were solved for 8, then that would leave a naked pair in block 2, and one of them has to be a 9, so those 2 red 9s would be false. And lastly, if pincer number 2 were solved for 9, of course, it would negate the 2 red colored 9s. So the conclusion here is that no matter how it turns out, at least one of the candidate C's must be true, here being candidate 9. It's a verity, which further means that these 2 red colored candidate 9s would have to be false, regardless of how the 3 XYZ cells are eventually solved. Now here is why pincer 2 cannot be 1 and 9. If this were the case and you solved the pivot cell for 8, then these 2 blue cells could both be 1, and that would not negate the 2 red colored 9s. So that can't be. That is not an XYZ wing. But here is where it gets a little tricky. If the pivot cell contains 1, 8, and 9, and if pincer number 1 is 1, 9, then pincer number 2 can be 8, 9 like this, or it can be 1, 8. Okay? This still works as an XYZ wing, but then of course candidate C becomes candidate 1, and it would look like this. You could eliminate those 2 red colored candidate 1s. And the XYZ wing would still work the same way. But just to keep it simple, we will always call the candidate that appears in all 3 cells our candidate C, okay? So here are the characteristics of an XYZ wing. There will be 3 cells with 3 candidates, A, B, and C. 2 of the cells will be bi-value cells containing AC and BC. And then there will be a pivot cell containing all 3 candidates. One of the bi-value cells will be in the same block as the pivot cell, and the other bi-value cell will be in the same row or the column as the pivot cell, but outside the block. And one of the 3 candidate C's must be true. Therefore, any same-digit candidate that can see all 3 instances of candidate C can be eliminated as false. Now, before we get to the real examples, here are some tips for knowing when there is not an XYZ wing or when there are no eliminations to be made, which will hopefully save you some time when you are looking for these things. What you want to do is check the blocks one by one for these conditions. First, there must be a bi-value cell in the block. If there is no bi-value cell, then there is no XYZ wing, because that's our pincer number 1. And second, there must be a cell with 3 candidates in the block, and that will be the pivot cell. And the pivot cell must hold the same 2 candidates as in the bi-value cell, plus a 3rd candidate. If you don't see those 2 cells, then immediately move on to the next block. Now, if you do see those 2 cells, before you go looking for your pincer number 2, first look at the intersection of the row and the block containing the pivot. If the 2 other cells are solved like this, or if they do not contain any other instances of A, B, and C, like this, then even if you do find an XYZ wing, there will be no eliminations. So again, if you see that, then just move on to the next block. Please note that you will not know which candidate is candidate C until you find an appropriate pincer number 2. The cell in row 3, column 8 can be 8, 9 or 1, 8. And you don't know which candidate is candidate C until you find that cell. Now, whatever candidates are in pincer number 1, then pincer number 2 outside the block must contain one of those two candidates, which will end up being our candidate C, coupled with the other candidate from the pivot cell. Got it? Okay, let's take a look at some real examples and some real puzzles. All right, let's try what I just recommended. Let's go through the blocks one by one and look for XYZ wings. So in block 1, it looks like we have some possibilities. We have 2 by-value cells, and we've got a cell with 3 candidates, and the cell with 3 candidates contains the candidates in the 2 by-value cells. So that looks pretty good. So let's start with this as maybe pincer number 1 and this as our pivot. Now, because pincer number 1 and the pivot cell are in the same column, pincer number 2 cannot be in that column because that would be a naked triple. So the only place for pincer 2 would be in row 2 outside that block, but we see the 2 elimination cells are blocked with 2 givens. So there's no possible elimination looking at it that way. So let's try it the other way. Let's say this is our pincer number 1 and that's our pivot. Now, because pincer number 1 and the pivot are on a diagonal, that means pincer number 2 can be either in the row or the column, okay? Because that would not create a naked triple. But we know from just a minute ago that it can't be in row 2 because these cells are already blocked. So the only possible place for pincer number 2 would be column 2, and it would have to be a 1 and a 2 or a 1 and a 5 because 1 is our candidate B, okay? So now if it was 1 and 2, then there would be a naked pair of 1 and 2 in the column, and you could solve the pivot cell for 5. So it can't be 1 and 2, so it can only be 1 and 5, and there is no by-value cell in the column with a 1 and a 5. So this turned out to be a total bust, and there was nothing there, so we just move on to block 2. All right, so here in block 2, we've got 2 by-value cells, and we've got 2 cells with 3 candidates each, and the cells with 3 candidates contain the candidates with the by-value cells. So we've got some possibilities. So let's start with this as our maybe pincer number 1 and this as our pivot cell. So because these 2 cells are in the same column, pincer number 2 cannot be in that column because that would be a naked triple. Remember, an XYZ wing cannot lie in a straight line. So it can only be in row 3, and we see that these 2 cells are blocked, so there is no chance for a possible elimination. So we just throw that out and don't even look any farther. Okay, so let's get rid of those colors. And now let's use this as our pincer 1 and this as our pivot, 4, 5, 4, 2, 5. And since they are on a diagonal, pincer number 2 can be either in row 2 or column 6. And we see that the elimination cells are not blocked. So let's take this one step further. And since pincer number 1 is 4 and 5, pincer number 2 has to be 2, 4 or 2, 5. So look in the row, is there a 2, 4 or 2, 5? Nope. In the column, is there a 2, 4 or a 2, 5? Nope, there is nothing there. So now we move on to block 3. And once again, we have some more possibilities. Here's a possible pincer number 1 and a possible pivot cell that contains those 2 candidates. So pincer 2 cannot be in the row because that would be a naked triple. So it can only be in column 8, and it would have to be 3, 1 or 3, 7. But there is no 3, 1 or no 3, 7. So let's move on. And now we have another possible pincer cell here with 5 and 6, and then we have a 5, 6, 3. So pincer 2 cannot be in row 3. It can only be in column 8, and it would have to be 3, 5 or 3, 6. But there is no 3, 5 and there is no 3, 6. So lastly, we have 2 and 5 as a possible pincer and 4, 2, 5 as a pivot. But because pincer number 1 and the pivot cell are in the same column, pincer number 2 can only be in row 2, and we see that these 2 cells are already blocked. So that means there's no chance for an elimination, so now we're going to move on to block 4. All right, here in block 4, we've got a couple of by-value cells, but there's only one that matches up with another cell that has 3 candidates, and that would be pincer number 1 and a possible pivot right here. So pincer number 2 cannot be in row 5 because that would be a naked triple, so it can only be in column 3. And we see that in column 3, the 2 elimination cells are already blocked with 2 givens. Even though there was a valid pincer 2 down here with this 8 and 6, that would have been an XYZ wing, but there's no place for an elimination to be made, so before you even look for that 8, 6, you would just move on to the next block. So here in block 5, we've got a pincer number 1, and we got 2 possible pivots. So let's try this one first. And because they're on a diagonal, pincer 2 can be either in the row or the column, but the 2 column elimination cells are blocked. Let's mark them red. So it can't be there, so it can only be in row 4, and we would need it to be a 3-5 or a 3-6, and there is no 3-5 or 3-6. So now let's do it again with the other pivot cell. If this is pincer number 1 and this is our pivot, pincer number 2 cannot be in the column. So again, it can only be in row 4, and it would have to be 3-5 or 3-6, and there is no 3-5 and 3-6. So now let's move on to block 6. And finally, here in block 6, we have a pincer number 1 and a possible pivot. And so pincer number 2 would have to be in column 9, and it would have to be 5-6 or 5-7. And sure enough, we've got a 5-6 up in row 3, column 9. So here we have a real XYZ wing. And so candidate 6 is our candidate C, because that's the candidate that appears in all 3 of those cells. So that means any candidate 6 that can see all 3 of those 6s will be false, and there are 2 of them, one here and one here. So you can eliminate both of those candidate 6s. All right, so let's move on to the next puzzle, and we won't examine each block one by one in the rest of the diagrams. We'll just cut right to the XYZ wing, okay? Okay, here in this puzzle, let's take a look at block 2, and we've got a pincer cell here with 7 and 6, and we have a potential pivot cell with 7, 5, and 6. So now we need a pincer number 2 with either 5, 7 or 5, 6 that lies in either row 2 or column 5. And we see down here in column 5 is our pincer number 2. Now don't forget, in an XY wing, pincer number 1 does not have to be in the same block with the pivot cell. It can be, but it does not have to be. In an XYZ wing, pincer number 1 has to be in the same block with the pivot, and then pincer number 2 will be outside the block in either the same column or the same row as the pivot. So here our candidate C is candidate 7. That's the candidate that appears in all 3 of those cells. So any other candidate 7 that can see all 3 of the 7s in those 3 colored cells will be false, and in this puzzle there are 2 of them. There's one here and one here. Those 2 7s can see all 3 of the 7s in the 3 XYZ wing cells. So you can eliminate both of them as false. All right, let's go to the next one. All right, here in block 9, we've got a pincer number 1 with 1 and 5, and we've got a pivot cell with 1, 5, and 8. So that means pincer number 2 can only be in row 7, and we need it to be 8-1 or 8-5. And we see we have an 8-1 right here. So that means candidate 1 is candidate C, and any other candidate 1 that can see all 3 of those 1s will be false. And in this puzzle, there is only 1, and it's right there. So you can eliminate that candidate 1 as being false. All right, next puzzle. All right, here in this puzzle in block 5, we've got a pincer number 1 and a pivot cell and a pincer number 2. So again, candidate 1 is our candidate C, and there are 2 candidate 1s in this puzzle that can see all 3 of those candidate 1s in the 3 XYZ wing cells. Okay, let's go to the next puzzle. All right, here's our pincer number 1, here's our pivot, and here is our pincer number 2. Candidate 5 is candidate C, so we can eliminate these 2 candidate 5s because they can see all 3 candidate Cs. All right, next one. Okay, here we've got pincer number 1, our pivot, and pincer number 2, and candidate C is candidate 9. So these 2 9s are false and can be eliminated. Okay, all right, let's go to the next one. All right, here we've got pincer number 1, we've got our pivot, and pincer number 2. So candidate C is candidate 2, which means these 2 candidate 2s are false because they can see all 3 of the candidate 2s in the 3 colored cells. Okay, next one. All right, here's our pincer number 1, our pivot, and our pincer number 2. And candidate 3 is our candidate C, so that means any candidate 3 that can see all 3 of those cells will be false, and here there's only 1, and it's right there. So you can eliminate that candidate 3. All right, next one. All right, here in this puzzle, candidates A, B, and C are 1, 4, and 5, and here's pincer 1, here's your pivot, and here is pincer number 2. So any candidate 1 that can see all 3 of those cells will be false, and in this puzzle there's just one. It's right there, and you can eliminate that candidate 1. All right, next one. All right, here are candidates A, B, and C are 5, 8, and 6, and here's our pivot cell, and here are the 2 pincer cells. And so candidate 5 is candidate C, which means any other candidate 5 that can see all 3 of those cells will be false, and it's right there. There's just one, and you can eliminate that candidate 5. All right, these are going pretty fast, so let's do a couple more, and then we'll wrap it up for today. All right, here in this puzzle, our A, B, C are 2, 9, and 7, and there's our pivot, and up here we've got 9, 7, and down here we've got 2, 7. So there's an XYZ-Wing, and candidate 7 is candidate C. So any candidate 7 that can see all 3 of those cells will be false, and here there are 2, and you can eliminate both of those candidate 7s. All right, let's go to the next one. All right, here in this puzzle we've got 1, 4, 6, and up here we've got 1, 6, and down here we've got 1, 4. So there's your XYZ wing, and candidate 1 is our candidate C, so we can eliminate these 2 candidate 1s. Okay, let's do another one. All right, here in this puzzle in block 2, we've got 3, 5, 9, and our pincer 1 is 5, 9, and our pincer 2 is 3, 9. So there's an XYZ wing, and that means any candidate 9, which is our candidate C, that can see all 3 of those cells will be false. And here there are 2. There's one here and one here. Those 2 9s can see all 3 of the 9s in the colored cells, therefore they can be eliminated. All right, let's do one more. All right, here in this last puzzle, our pivot cell is 4, 8, and 5, and here's pincer number 1 of 8 and 5, and pincer number 2 of 4 and 5. So of course, candidate 5 is our candidate C, and so we can eliminate any other candidate 5 that can see all 3 of those cells, and they are right here and here. There's 2 of them, and they are both false. All right, that's going to do it for today, so let's go back outside and finish up. Thanks for watching. Okay, so those are XYZ wings. They are not quite as common or as easy to spot as an XY wing, but I'm sure you will find them to be very useful. In the next video, video number 25, we will learn about what are called W wings. These work just like an XY wing, except that the pivot is a conjugate pair instead of a bi-value cell, and they only incorporate the use of 2 candidates at a time instead of 3. W-wings are a very powerful technique, and quite often you will find that 1 or 2 of them will unlock a puzzle when you get stuck in the later stages. So I hope you will join me for that very important and interesting lesson. In the meantime, be well and be happy.